Right, here's your video on forces, the second one. So here we need to look at what a force is. So forces cause one of the following things. They can cause an increase in speed. They can cause a decrease in speed. Or they can cause a change in shape, or a change in direction. A good example is heading a ball. When you head a ball, you make its direction change, you change the shape of the ball. It slows down as it hits your head, but as it bounces back off again, it speeds up. So heading a football will do all four of those things. There are 9 different forces you need to know about. Pulling something doesn't have to be a rope, but pulling everything puts it under tension. So we say there's a tension force there. Okay? Now, anything that's falling is falling because of its weight due to gravity. So we say it's weight. So the force that causes objects to fall is weight. If we open a parachute, our speed reduces. That's because air resistance increases due to the surface area of the parachute. So air resistance is an example of a force. That also slows us down when we're running, or slows the car down when it's moving. We have also got a normal force. The normal force acts on objects, okay, stops them from going through that object. So for example, standing on that table, gravity's trying, or weight's trying to pull him down, the normal force pushes up. Normal forces come from solid objects. If you were to run into a wall, that would still be the normal force from the wall stopping you from going through it. This force is upthrust. Upthrust makes things float. Okay, that could be floating in air or in a liquid. If we push that balloon underwater, it will pop back up because of upthrust. Then we've got compression, which where we basically squash things. Okay, so that's a compression force. We've got a magnetic force, which we've got here. Okay, so that's when magnetic fields attract metal objects. We've got friction, which is when two surfaces rub together. And then we've got electrostatic, is when charges cause movement of things. So difference in charges, a positive and negative. Now, some of these are contact and some of these are non-contact forces. So contact forces are forces where the objects need to touch for that force to act. Non-contact forces are where there doesn't need to be any touching between objects. So we'll put a C next to the contact ones. Tension, you're having to touch the rope, so that's contact. Weight, you're not having to touch anything, so that's non-contact. Air resistance, you're touching the air, so that's contact. Okay. Normal, you're having to touch the table, so that's contact. Upthrust, you're having to touch the water, so that's classed as contact. Compression, you're having to touch the spring, so that's contact. Magnetic is non-contact because you don't have to touch the paper clips. You can move the paper clips with a magnet without touching them. Same idea with a balloon. You can see that hair is standing up on end without the balloon actually touching the fur. Okay, so again, that's non-contact. I'll put that on the outside, otherwise you won't see it. And then friction, the two surfaces have to touch, so that's contact. Now, you've got the different forces. Now we need to look at what happens when the two forces interact. So, when the two forces interact, one of 3 things can happen. These are only going to be the answers that you need. Constant speed. It's either going to be a constant speed, which includes stationary as well, okay? And then you could have increase in speed or decrease in speed. Okay, so these are only the answers we're going to use. Now, it's important we know what happens before. Okay, so if we have a look, we always draw a box to represent the object we're talking about. That just speeds things up. But this object could be anything. It could be a car, it could be a plane, it could be a skydiver. And in the center of the box, we mark something called the center of mass. It's really important you remember that. We call that the center of mass. Now I'm going to choose some random arrows. I'm going to draw some random arrows to represent that. So, first of all, we must know the direction which that object is moving before those forces act on it. And that's usually said in the question. So it'll say this car is moving at a constant speed to the right, like we've got in this case. And then these forces act on it. Okay, so we can have that force, and we can have that force. Now, forces are vectors because they have equals a vector, because they have a direction and they have a magnitude, which means size. So the arrow points in the direction we're talking about, and the size we're talking about is represented by the length of the arrow. So we might have 50 newtons here and 20 newtons there. Now, we say, because there's a difference of 30 newtons between the two, we say it's got a resultant force, so we can say resultant force of 30 newtons to the right. Okay, now we've got to say both for resultant force, the 30 newtons to the right. And then we know if they're moving this direction, okay, and there's more force to help it in that direction, it's going to speed up. We know it's going to speed up because that force, there's 30 newtons to the right, and that's helping it move in the direction that it's already moving. Now, if we draw another one, but this time we have the same forces acting on it, 50 newtons to the right, 20 newtons there, but we've got it's moving to the left, okay? We've still got a resultant force of 30 newtons to the right, but it's working, the resultant force is working against the direction in which it's moving. So as a result, it slows down. Remember, we're only using these terms. So speeding up meaning increasing in speed, slowing down meaning decreasing in speed. Now, we draw our final one, okay? And I'll have it going to the right, like the first one. But this time we'll have the same force on either side. Now, in your exam, you'll have to measure those. You can see this one looks to me slightly longer. But in your exam, you have to measure them to make sure your diagrams are exactly the same. Okay, but I'm going to label that as 50 newtons and 50 newtons. Okay, that means the resultant force is 0 newtons. There's no direction because the direction, there isn't a larger force in a specific direction. So we just say 0 newtons. And whenever it's 0 newtons, it's always a constant speed. And we know it was moving to the right, so we say constant speed right. Now, if it was stationary, okay, if it said there was the object was stationary, and then we had equal forces left and right, we would write stationary there instead, but it's still a constant speed. Hopefully that helps. Thank you.